the appliance arena.
Okay. Hello, nice to meet you. Here we are showing our smart cooktop, where we have two different technologies. The one technology is coming from wheel controls, the 3Sense technology, where we can detect three different states: a proximity, a touch, and a press. And combining these, we can also detect simple gestures like swiping or having a hold, or also tapping if you want. And everything is running on the RT1060 crossover MCU from NXP, which is also AI-based, the algorithm. And on the top, we have the person detection, which is running on the MCX N series, which is also including an NPU. So all the pictures that you can see here, which is detecting a person who is standing in front of the cooktop, is processed locally. So there's no picture, no data distributed to the cloud or to an external server or whatever. So doing so, let's assume that we want to cook something. I switched on already the first burner. Now I'm doing the second one. We have chosen press for the switching on because while cleaning, it can happen that you are having false positives if you are just using touch as you are used to it at the moment. With press, you do not have it. And furthermore, you have a kind of a child protection as well with the press. Now I have to select one plate. Let's choose the left one. I'm doing this with touch. You can do it also fully contactless if you would like, but also for having long proximity if you want to do it like this. Now I want to increase the temperature. I can do it by hand for sure, but I can do it also with gloves. And this is something which is unique in comparison to capacitive solutions, for instance. So this is normal gloves as you know it. Now the pot is getting hotter and hotter, and after some while you will get some critical state. At the moment, you can see the person detection is recognizing who's in front or that there is someone in front by the white box around my face. If I go into the critical state, which we simulated by a hold gesture because we don't want to burn down the CES, you can see it's fading and the cooktop is doing nothing, which is good because maybe I did a critical state on purpose. Maybe I need the high temperature, the fire for some special dishes. But what happens when I will disappear? So now you can see the cooktop knows that there is no one in front of it, and it brings the system immediately to a safe state. So the system recognizes that this is not on purpose, and it prevents you and your home and your beloved ones from damage. And what I would like also to highlight again is all the images are processed on the microcontroller, so on the MPU, which is optimized for AI algorithms to operate on.
So how do you deal with the situation where you're boiling a pot of water? You're not necessarily going to stand. You're not going to leave it alone. But you're not going to stand in front of the stove. You might go, to the dining room table to do something while you're still keeping an eye on the stove. How would you deal with that kind of situation?
Yeah, that's the point. At the end of the day, you can leave the system. It doesn't matter because as long as it is not in a critical state, it will still burning. Everything is fine. But if you reach a critical state, like a boil over and so on, then you want that the system is reacting and shutting down the system.
That's all going to be temperature based, right? If boiling a pot of water is not going to be the same temperature as something that's water's all boiled out and it's overflowing, the water's gone and the pan's just heating up, right? So that's what it's really looking for, those types of states, because it's going to recognize that hey, this is a normal temperature to be able to be operated around and some of the things. So one of the things that Thomas is talking about the fact that this is all kind of locally based, it's all self-contained in this unit, but it also is connected. And so, as we talked about outside, as it reached that high temperature stage, you can see in the cooktop right there, it reported to the system, so the system can notify the homeowners, it can react to the state and what's happening in the home. And so it's like, it can shut off on its own, but it's also can say, hey, I shut off, something happened, and so you can be aware. If you're not home, or if you left your son at home, he's cooking and you forgot and walked upstairs and left it on, which can happen, right? So, okay, so from there, thank you, Thomas.
You're welcome.
So I'm going to quickly, we've been talking about this home experience, kind of how it all kind of interacts and works together. I want to do kind of a brief pause and talk about kind of that enablement to accelerate this, and how can we get this into our homes? How can we get all these products on the shelves today? One of our partners, MicroEge, as they pronounce it, the MicroEge here, partnered out of France, just announced last week of a collaboration with NXP called the NXP Platform Accelerator. And the value of this is It's about accelerating developments and getting products to market. And one of the ways that they've been able to do that is through a software virtualization. They're using containers that allows a single app development. So for instance, if you developed an Android app in the Android Studio and you developed it so that it could, have that whole kind of look and feel and interactive, nature of that you want in your app, you could certainly run it on a device that can run the Android OS. So the 8M Mini is a device that's already capable and enabled and has all of the capabilities to run Android OS, and so you have an Android capable app there. But that same app can also, if you don't need an Android OS capable app device, you could actually even run it on something as simple as a microcontroller, and that containerization that they've enabled there to run on either a microcontroller or a Linux-based controller or an Android-based device. That same development can just go across. So you have portability across it, and you have the scalability. So you can have either cost or performance-based decisions on how which device that you want to run this app on, and then that'll accelerate your development there. Okay, that's good. Okay, so as we progress from this, we're going to go into one of our favorite parts of the room, and that is our entertainment room. So we're going to go into movie time now. Okay, so what's going to happen is we've left the phones on the kitchen counter. You might not see that, but the phones are there. They're over there. And so, hey, how can the home interact with us and know where we are without the phone? And that's one of the exciting things that we have now is our UWB capability expanded from ranging to radar. And what that means is it can detect the person and where they are in the room. And then based off of that, the intelligence intent can then the intelligence can understand the intent. And so in this case, we're going to have somebody, one of our guests here, sit on the couch and be ready in just a moment, ready to watch the movie. And you'll see on the right-hand side, it'll detect that. It'll understand the intent. Hey, it's movie time. And so it'll switch over into an entertainment experience there. You'll see the blinds, because not only is the entertainment going to turn on, but the blinds and the lights are going to interact, and you're going to be ready for movie time. Okay? If that's all right, you want to head over here?
The radar up there?
The radar is not up there. It's actually right there on the console, and it's basically could be either in the TV or it could be in the sound bar. So if you want to step around. Thank you. There's room here if you want to come down as well. Hold on a second, Haku, just a second. Yeah, so let me just do this. So if you take a look at the screen, it just detected that, hey, we've got people on the couch. They're ready for a movie, right? And then it's also showing the speakers, which Haku will talk to in a moment, okay? But the biggest thing is the radar that's centralized there is in the soundbar area, and it's being able to understand that we have presence in this area. And so it's detecting presence. Radar has the capability of doing other things, looking at breathing rates and things like that. And so there's a lot of exciting use cases that it can do to understand where you are in the home and your intent. And so that's part of the exciting the evolution of UWB and that sensing capability. So from here, I'm going to turn it over to Haku, who's going to talk about this, what we call UWB sonic optimization, which is where we're using UWB, not only radar detecting, but we actually have UWB in each of the individual speakers to be able to have an optimized audio experience. And part of that we've enabled with UWB, and each of these speakers actually are wireless, so they're running audio over Wi-Fi. So which means in some cases they're really untethered. Other than power, you can move them around and you can adjust them, and that's part of the the value of what we can do in this experience. Yeah.
So on this radar situation, it's more of just presence, not identification, right?
Right now, it's
yes. That it's a child or an adult.
Currently, that's what it's now. Radar obviously has a lot of information that it can detect, and it'll continue to enhance its capabilities. But things like breathing and certain size of the person, whether it's human or not. And it's really just up to our customers to take that data and add their special algorithms to be able to do that kind of understanding there. So I'm going to turn it over to Haku, who's going to explain a little bit of this optimization experience. So, but good question.
Alrighty. Okay. So what we have here is basically a turnkey solution that is enabling all the wireless audio through speakers and using Wi-Fi and also UWB. So imagine one thing is that this is actually a future type of products for audio. And what's really exciting and very different about this is that the employment of the UWB technology for both distance and angle measurement, and also for the personal detection through UWB radar. So on a traditional system, the current system for audio right now actually uses acoustic measurements through microphone, and you have to calibrate all the audio information for specific room every time. And once you actually knock the speaker's position off, you have to recalibrate every time, getting the microphone out and everything. So that can be a little bit tedious, but what you want to do is that by having the UWB capability, you are able to actually recall the positional information. So if you take a look at the speaker there, for 4 speakers, 3 of them are green, means that it's in an optimal location, but one is actually off the location. So I'm asking Alexis to actually move the speaker. As you can see, as the speaker moves, the speaker information actually gets updated and recalls the position where it is actually calibrated to. So what we want to basically do is that we want to enhance, not to eliminate the acoustic calibration, but to complement and expand the technology, and also to up the experience and the ease of use cases for the audio experience. So that's the demo for the UWB.
All right. Got any other questions? All right. We're gonna thank you for your time today. We're gonna exit the room, and if you have any other questions, you can step outside and ask us. Thank you very much.